Hello, welcome to our channel for probability and statistics. In this video, we will talk about tests on an individual coefficient in multiple linear regression model. So if we have a multiple linear regression model, y equals x beta plus epsilon. So epsilon is a random term with mean 0 and standard deviation sigma. And x is the matrix of independent variables, and beta is a column vector for the coefficient. So if we have estimated this model, get the coefficient beta, so next step, we most probably will want to test if each of the individual coefficients is significant, because the addition of any single variable a single coefficient to a regression system will increase the regression sum of squares and thus reduce the error sum of squares. And this addition may not be necessary, because if the addition of the variance estimated by the model from the single coefficient and from the single variable will be very little compared to total variance of error term. So maybe this coefficient or this variable cannot be added into the model because this is the overfit of the model. So we have to test the significance or the effectiveness of the inclusion of single variable. So first we show some mathematical notation. So this is independent variable plus a scalar vector, and this is x transpose times x and takes inverse, then we'll get a scalar matrix C00 to C22. And for the ANOVA table for linear regression or multiple regression model, this is the SSR, which is the variance as explained by the model, and this is SST for the total variance of the response variable. And the difference of these two called SSE, which is error terms sum square. So error term take square and take sum, then divided by its degrees of freedom called MSE. We will also call this term as S square. So S square is estimation of the variance of epsilon. So we have this mathematical notation. So next we will test, say, single coefficient if it is significant. So from the examples we have shown in many of the videos in this channel, so we get, for example, a linear regression model with 3 independent variables. And now we will test if the third variable, beta 3, is significant or not. So the null hypothesis is beta 3 is 0, and alternative hypothesis is beta 3 not equals to 0. So we can use the t-distribution or t-test for this beta. So this B3 is the estimation of the coefficient from the model. Then we minus 0, then divided by a term. This term is the product of S. S is the square root of S square, and take a square root of C33 in the previous matrix. Though this term production actually is the standard error of B3. So the division of these two parts will be minus 0.556, and this follows a t-distribution with 9 degrees of freedom. So you can see this term is not in the critical region, because the critical region is about minus 2, less than minus 2, or larger than 2. But this value is between these two critical values, so it's quite not significant. And this indicates beta 3 does not differ significantly from 0. We will hold this null hypothesis and we can say we have to remove x3 from the module. So this is the t-test to test the significance of one individual variable should be included or not included in the module. And if we use another alternative called f-test, an f-test actually is an ANOVA type test. So if we calculate amount of variation in the response that is attributed to x3 in the presence of the variable x1 and x2, so we have to calculate this term called R beta 3 given beta 1, beta 2. And this term is the total SSR. SSR, if we look at the table, so this is the SSR. We include 3 variables in the module, and this module can explain how much percent of the variation of the total SST of the response variation. So this is SSR. And this SSR minus another SSR we call R beta 1 beta 2. So R beta 1 beta 2 is a module which having not variable 3 in this module, only variable 1 and variable 2. So the difference of these two variation explanation by these two modules is the contribution of the variation explained by only variable 3. So this term about 1.33. So this actually is a very small proportion of the entire regression variation explained by this variable inclusion. So we have to test using ANOVA. So ANOVA is a f-test which is 2 parts of variation division. So first is the variation by variable 3 because it has only 1 degrees of freedom. So we can omit division by 1. And S square is the total error sum square, which is the SSE divided by its degrees of freedom. So the division is an F value, is a value followed with 1 and 9 degrees of freedom of a F distribution. So you can see this is not significant in the F-test also. So we get the same result as we use the t-test for the significance of these coefficients. And if we recall that the F-test actually is, if F-test with 1 and V degrees of freedom, actually same as a t-test with V degrees of freedom. So the t-test statistic take square actually equals F statistics in the model. So if we look at F value here 0.309, actually it is the square of the t value of minus 0.56. So these two kinds of tests will get the same result. Thanks for watching.